Let's face it. Today I'd like to discuss a topic that's brought up quite frequently, and it has to do with whether or not we should fast on water, whether or not we should fast on juice, feast on juice, or how important are they to health, etc. And these are very important topics, and they actually branch off into many, many different ideas. So I would like to just cover a few of them today. The most important thing to understand about eating is that one of the most, or equally as important to eating, is not eating. It's the period of time when we don't eat is equally as important with the time that we do eat. They're both equal and they're both necessary, and they both are necessary in the ways that nature provides. Because we have to always look at nature as being the fundamental paradigm, the fundamental way it is. In Chinese, they call it the Tao. They also call it in Japanese that. The Tao, or the way. The way things are is the way nature is. So if we look at nature, we get an understanding of how those things can be brought into harmony and how they can be viewed as harmonious. So rather than looking at one or the other, we need to look at both. So not eating and eating are equally as important. So when we talk about life, what we're really talking about, when we want a happy life, we want a successful life, we want a productive life, what underscores all of this is the term vitality. It's the concept vitality. We want vitality. It's vitality. It's energy that gives us a great life. Okay, and with the energy and the vitality, we can accomplish many things. Without it, we can accomplish nothing. So we're really talking about vitality, which is energy, and where do we get our energy, and how do we maintain our energy? These are what we're really talking about. That's what these questions are really asking about. Now, in nature, what we'll notice is that all creatures live a life that requires intermittent fasting. For example, an animal may find food to eat for 1 or 2 days and then not find food for a couple days. And that's just the way things are. And it's not just the way things are and bad luck, it's the way things are, and that's very, very important, because the way things are the way they need to be. Because if they weren't the way they are, they wouldn't be. That's a concept that's really hard for a lot of people to accept, and it takes many, many years to really come to that complete comprehension. Now, the body is designed for this, intermittent fasting, because it helps remove the accumulation of toxins. And what are the results of the accumulation of toxins? Well, they are two things that we are very concerned about: aging and disease, what we call disease. Disease is really dealing with trying to correct and balance and maintain as much functional integrity as possible in the face of accumulated toxins. When we're talking about the accumulation of toxins, and that's what happens in aging. I mean, a simple example is age spots. You get a brown spot on your hand, you get a brown spot on your face. It starts happening with aging, and it's an inability to get rid of toxins. We finally, you pour water into the cup, and you can pour it in pretty freely, but once you get near the top, every drop is going to cause a spill. And that's where that's what aging is, and that's what disease is. When we talk about the animals, and we use that, and we understand that metaphor, we understand that they eat, what they eat is always appropriate, because animals eat under the auspices of instinct. They don't eat out of appetite. They don't say, I'm not going to eat that today. I'm going to go have this. They eat what's available, what's in front of them, and out of instinct. They're able to smell it or feel it. They have a way of knowing whether or not it's appropriate for their biochemistry. The toxicity of the body has to be looked at as having two aspects of it. And that is that part of the body which is outside, or that part of the body or the system that's outside of the cells. And we have about 100 trillion cells. And then there's that part of the body which is inside the cells. And they both have their own milieu, their own environment. Well, the outside of the cells, the fluid that bathes the cells, the fluid to which the cells develop a response, is called the extracellular matrix, the interstitial fluid. It's got a few different names in biology, but it's this fluid that bathes the cells, provides its nutrients, collects its waste, disposes of them, and it's this fluid that will signal to the cell what it needs to do. If there's a lot of glucose, it'll do one thing. If there's a lot of estrogen, it'll do another thing. If there's a lot of waste products, it'll do another thing. So the cell is always responding to what's in that environment. So it's the cleanliness of this extracellular fluid. Now we know that, and then as well as the intracellular fluid, but I'm focusing for a moment here on the extracellular fluid. So what we know about the extracellular fluid is that it has its input from the arterial system, and it has its cleansing or exiting through the venous, the blood vessels, the veins, and the lymphatics. So whatever's coming in the arteries, which is from our heart pumping and what we breathed in and have eaten, what comes in through our skin, all these sorts of things are in our arterial system that's being pumped to that fluid that bathes the cells. Okay, now it's being drained by the veins and the lymphatics, which do not have a pump. They do not have a heart. Not having a pump or not having a heart, they depend upon their functioning or the speed of their ability to move things along by muscular contraction. That's what our muscles do. Our muscles contract the vessels, and they act as a pumping action. Okay, so it's very clear. Activity, movement are necessary. You're not going to move and be active if you're not too vital, if you don't have too much energy. But anyway, that's the way things are moved along. And that these vessels have to be in a healthy condition. They can't have plaque inside of them. They can't have all kinds of residue. So that's the extracellular fluid. So it's what we're eating and drinking and breathing and putting on our skin, and it's what we're eliminating or not eliminating. Okay, that accumulates. Now, inside the cell are all the little organelles that do perhaps perform all their functions. Everything from mitochondria, which produce energy, the little energy factories, to the lysosomal system, which cleans it up, to the ribosomes, which make proteins. And there's many Golgi apparatus. There's all sorts of different little organelles that have specific functions that allow cells to do what they were designed to do. And in the center of it all is the nucleus, and in that nucleus is the DNA, which is the library of all the particular possible responses that cell is able to do. So now, all of those organelles are going to respond to what's happening in the extracellular fluid, if they can. Now, they're living in an internal milieu, and that internal milieu, that intracellular fluid, has, as I said, the little energy packages, anywhere from, they're called mitochondria, anywhere from 500 to 2,500 per cell. And their job is to keep about 1 billion ATP molecules available at any one time for energy, because of enzymes, which are functioning at the rates of 1 million times per second, need a lot of energy. And so this energy has to be, this energy production has to keep happening. Okay, so the energy is produced in the factories that take nutrients like glucose, fatty acids, and oxygen and burn them very efficiently to produce ATP. ATP are these molecules I was talking about. Now, during normal cellular processes, proteins that exist in there, such as these organelles, the ribosomes, the mitochondria, they become old. They're used a few times, they become ragged. And the normal process of nature is to recycle it. You know, that's how biology works. Biology does not spend too much time repairing. It'll make new ones, okay, and recycle. And when the entire cell recycles, we call that apoptosis. Most people are familiar with that term of apoptosis. What happens is this beautiful, wonderful, incredible system that, once again, can only leave us in awe of God, is the Autofaggy system, Autophagy. And basically that's the lysosomal system. There's another protein involved that does some of the work, but most of it is in the lysosomes. And what lysosomes are these little organelles that have a single membrane, and in them they have a very low pH. They're very acidic. And what they do is they see bacteria, viruses, other intracellular organisms. They see old ragged proteins. They see defective mitochondria, etc., like that. They engulf it, dissolve it, and put it out as trash to be extruded through the cell membrane if there's no use at all of it. Or if there is a use of it, it'll reuse the different parts to make different things. Now, in a period of time when we are not eating, there is no nutrient flow into the cell, what happens? Well, what happens is the cell says, and this is like we were talking about with the animals who have intermittent fasting. What happens is when there's no flow of nutrients, then all those things that are being gobbled up are used to make fuel. Proteins can be broken. They're not usually broken down for fuel. They're usually used to make parts, but they can be broken down for fuel. The same with fat and, of course, carbohydrates, glucose. So that's what happens. So during a time when nutrient flow is not coming in, the body, the insides the cells are taking these parts and converting them into usable energy. That's why when we stop eating, our body just really cleans house. Now, the beauty of this is that these old defective mitochondria are no longer that efficient at producing energy, which is why, and when you have enough of these mitochondria that haven't been renewed yet, what happens is you get a real decrease in your ability to produce energy. And that's what we notice when we have what's called illness or sickness. We start to get fatigued. When I'm old, I'm tired. So when we look at the difference between youth and old age and illness and health, it all has to do with energy. Okay, and the energy is produced in these mitochondria, as I said. So did you ever wonder why it is when you crawl into bed exhausted and you open your eyes 8-10 hours later and you're full of energy? What happened there? How did that happen? Well, what happened, for the most part, many things happened. But one particular thing that's extremely important is that the internal environment of the cell was cleaned up, and all the defective mitochondria were gobbled up, and new mitochondria were produced, because that's what happens. Mitochondria are continually being reproduced. So now you wake up in the morning and your cells are full of brand new, happy, healthy, vital mitochondria, and you jump out of bed, you leap out of bed. Okay, well, this happens not only every day, but it happens throughout life. So intermittent fasting is not only a good thing, it's an absolutely necessary thing. So therefore, when you consider the fact that animals eat intermittently, so what's happening is that they might have 3 or 4 days of nutrient input, and then 2 or 3 days of cleaning, and now all of the intracellular organelles are now vital again, and the energy is being produced. And this happening over and over throughout life prevents an accumulation or a premature accumulation of toxins. So that brings us to the point of how many meals a day. Well, the longer you can not eat every day, the better you are, the more clean you are. And in fact, one of the absolute truisms in all anti-aging medicine is that the less you eat, the longer you live. But you eat less, you live longer. Now, how do you eat less? Well, volume, frequency. Volume, frequency. Okay, so you're eating small volumes of really nutrient-dense food. Good, that's food that was designed for your particular biochemistry. And you're eating it infrequently. So breakfast doesn't mean the moment you wake up, you break your fast. You break your fast at some other time. Whenever you break your fast is breakfast. So if you went to bed and slept 8 hours and you wake up and you don't eat for another 4 to 5 hours, that's 12. Now if you wait even longer, you can get 15 hours. If you can get 15 hours, 18 hours between eating, then you have cleaned a lot. You are going to be vibrant. Okay, and then when you eat that food will actually be assimilated better. I hope that answers the question about fasting. Now, juice feasting is not fasting. Juicing is a liquid meal. And that's a whole different topic, and I will be happy to talk about that. It's also exceedingly important. Thank you.